For today's activity, we'll be doing the assessment plan 1A of the navigation 213, and the things needed: triangle rulers, pencil, compass divider, and chart number 9. So the scenario description for Aplan 1A is at 14:30 the vessel is at the vicinity of the southern part of Panay Island with rising tide and on course 278 degrees through with a speed of 10 knots. The officer on watch observed two lighthouses at the same time: the Libertad Lighthouse, which bears 90 degrees relative, while the Pusher Point Lighthouse bears 30 degrees relative. So after 40 minutes, Pusher Point Lighthouse bears 60 degrees true with a distance of 3.2 nautical miles, and the officer on watch altered the course to 16 degrees true by 10 knots. Then at 54 hours, Nasong Point Lighthouse bears 30 degrees relative. Then after 30 minutes, Nasong Point Lighthouse bears 90 degrees relative. So the task we need to do is to find the fixed position and convert the relative bearing to true bearing. So first is we need to convert the Libertad relative bearing to true bearing. So the Libertad lighthouse bears 90 degrees relative. So again, in order to change that to true, we need to add that to the ship's bearing or course, ship's course. So 90 degrees plus 278, so we'll have 368, but then 368 is over the 360 degrees on the compass repeater. We need to subtract those two, so the answer is 8 degrees. So that will be the first bearing for Libertad Lighthouse. So 8 degrees, 8 degrees here. Okay, 8. So that will be 8. 8. Then mark its line of position. That will be the line of position for the bearing of Libertad. The next one is the Pusher Point Lighthouse, which bears, again, a relative bearing of 30 degrees. So we need to add that to 278. So 278 plus 30 will have 308. So that will be the true bearing of Pusher Point. So 308. So this will be 308. Be 308. And mark its line of position. So that will be the bearing for Pusher Point. So this is Libertad Lighthouse, the bearing of 8 degrees true, and Pusher Point Lighthouse, which has a bearing of 308 degrees true. So now we need to mark the line of position for the ship's course. So the ship's course is 278 degrees. So 278. That will be 270. That's 278. Wait. That's 278. Then mark its line of position. So this will be 278 degrees through with a speed of 10 knots. So now we have the fixed position on 14:30. So this will be the ship's fixed position on 14:30. Is 14:30 hours. So after 40 minutes, Pusher Point Lighthouse bears 60 degrees true. So Pusher Point Lighthouse after 40 minutes, it is 60 degrees. 60 degrees. This will be 50, 60. Okay. That will be 60 degrees. Okay. Wait. 60 degrees. Then mark its line of position for Posho Point Lighthouse. Okay. So it has a distance of 3.2 nautical miles. So as we can see here in the latitude, this is 45 and this is 50. So basically the interval is 5 minutes. So we need to find the 3.2 nautical miles. So 1, 2, and 3. Since every interval from 1 to 2 is 0.2, so we'll have 1, 2, 3. We'll have to find it using this one. So that is 3.2. Then mark its center of position. Circle of position. So that will be the distance. This is Posho Point Lighthouse. Posho Point LT, which is 060 degrees through with a distance of 3.2 nautical miles. Then the officer on watch altered the course to 16 degrees through by 10 knots, still the same speed. We need to find 16 degrees. 16, so that would be 16, and that's 15. 16. Okay, that's 16 degrees. I just use the other ruler since it's bigger, longer. So 16 degrees, that will be 16 degrees. Then mark the ship's course or the ship's line of position. So that will be the ship's course with 16 degrees true bearing and 10 knots of speed. So now we have the fixed position of the Posho Point Lighthouse on 15:10 hours. Then at 15:54 hours, Nasong Point Lighthouse, this Nasong Point Lighthouse, bears 30 degrees relative. So again, we have a relative bearing. We need to add that to the current ship's bearing or ship's heading, which is 16 degrees through. So 30 degrees plus 16, we have 46 degrees through. So that will be the first bearing for Nasong Point Lighthouse. On 15:54. So we have 46. So this is 40. So this is 46. That is 46. Okay, so that is 46. Mark its line of position. There. Then, after 30 minutes, the bearing of the Nasong Point Lighthouse changed to 90 degrees relative. So again, we need to add 16 to that since it is a relative bearing. 16 plus 90 is equals to 106 degrees. So we have 106. So this is 100, 106. So that is 106 degrees. Wait. 6 degrees. Yep. 106 degrees. So this will be 100, 105, 106. Then mark its line of position. So we now have the two LOPs for Nasong Point Lighthouse. So this is Nasong Lighthouse with a bearing of 46 degrees true. Then this is the Nasong, after 30 minutes, the Nasong Point Lighthouse, just 106 degrees true. So now we need to find dead reckoning position on 1554. So from here, 1510 to 1554, we have 44 minutes interval. So we need to change that to nautical miles. So in changing that, we need to divide 44 by 60, 1 hour. So that will be 0.73. Then multiply it by the ship's speed, which is 10 knots. So times 10. So we'll have 7.3 nautical miles. So we need to find it using a compass divider. So this is 45, 1, 5, 6, and 7. Then 0.3 is in between 0.2 and 0.4. So it will be right. So 5, 6, 7, it will be right here. Then mark its center, a circle of position, like that. So that will be our dead reckoning position on 1554. So dead reckoning 1554 hours. Then we need to find the running fixed position at 1624, but first we need to transfer the first LOP to the dead reckoning position. But as we can see, it is already the first LOP is already on the dead reckoning position. So we'll go and find the running fixed position on 1624. So from 1554 to 1624, we have a 30 minutes of interval. So again, we need to divide it by 60, or 1 hour, 60 minutes. We have 0.5, then multiply it by the ship's speed, which is 10. We'll have 5. So that will be its distance, 5 nautical miles, from 1554 to 1624. So 1554, that will be, this will be the 1624 hour. Then we need to transfer the first LOP to here to find the running fixed position of the ship. So this is 46 degrees. Again, we need to find 46. This is 46. Then transfer that first LOP to that 1624, and this will be the running fixed position of 1624 hours. So we've done all the tasks, and lastly is to find the longitude and the latitude for the first fixed position, which is here, 1430. So the first fixed position, we need to find its latitude first. So its latitude is, so since this is 11, this is 11. So 11 degrees and 43.8 minutes. So 11 degrees and 42, 42. 43, 44, 42. Yes, so 11 degrees and 42.8 minutes. For its longitude, this is 121. So its longitude is 121 degrees and 51, 52, 53, 54, 55.2.4.6. So 121 degrees and 54.6 minutes. Now for the second fixed position, and 1510, this one. So its latitude is 11 degrees and 44.3 minutes. For its longitude, so we have exactly 121 degrees and 45, 46, 47, 48, 121 degrees and 48 minutes. Now for the third, the running fixed position. So for its latitude, it's 11 degrees, 51, 1, 2, 3, and 4. So it is 11 degrees and 54.8 minutes. For its longitude, there. So that is exactly 121 degrees and 50.2 minutes. And that is all for this video. Thank you.